So this example is a little bit different. The applied force might not be obvious just at first glance, but if we look at it a little more deeply, we can find it. So a snowboarder comes down a hill, reaches the bottom of it, glides to a stop in 16.4 meters. The total mass of the board and the rider is 64.2 kilograms, and the important thing here is the coefficient of kinetic friction is 0.106. So the work in this case is actually being done by friction to slow down the snowboarder. It's the friction that changes its motion from moving, to stopped. So what we know, I'm going to work a little bit backwards here, is that work is force times displacement. And the force here is actually the force done by friction. So, backing that up a step, we know that the force of friction, kinetic friction in this case, is mu times the normal force, or mu times mg. So knowing that, we can work backwards and define the variables. We know that the displacement of this snowboarder is 16.4 meters. The mass, 64.2 kilograms. Coefficient of friction, 0.106. Don't need to define g because g will always be 9.8 meters per second squared. So now we can go find the force of kinetic friction, 0.106. I am going to have to do this on two lines. There is no nice way for me to squish this. So 0.106 times the mass of 64.2 kgs times 9.8 meters per second squared. Gives us a 67 Newton frictional force. Can take that over to the work calculation. Force is 67 newtons. Displacement 16.4 meters. Multiply that out, going to 2 sig figs, we get the work done is 1100 joules.